Hi everyone, welcome back to my channel. So I'm here. Today we're solving the DSA problem. This was in the recent biweekly contest 168. Maximize sum of squares of digits. So this is the second problem. It's tagged medium. So the question, let's read it carefully. You're given two positive integers num and sum. A positive integer n is good if it satisfies both of the following. The number of digits in n is exactly num, and the sum of digits in n is exactly sum. The score of a good integer is the sum of the squares of digits of n in n, so it's like magnitude. And they want us to return the good integer from n the good integer from the given num and sum that achieves the maximum score. And they're telling us that if there are multiple possible integers that have the maximum score, then we should return the maximum number. And yeah, the edge case, if there's no such number, then we return an empty string. Let me bring out my notes app. So let's start with one of the given examples. So the first example was that num. Okay. So let's start with the first example. The first example was that num was given to be 2 and sum was 3. So our job is to find that n such that it has number of digits, which is it has 2 digits, and the sum of these numbers n1 plus n2 is equal to the sum, which is 3. So this is the question, and you can think of answers like this. For example, you can think of 30, you can think of 12, and you can think of 21. All of these are 2 digits and they have the sum of 3, but the answer to this question would be 30, because the magnitude of the sum of squares of the digits is 9, which is greater than whether it's 12 or 21, in which case it would be 5. So this is one example. So let's take a look at the second example, the S case, which they've given. So over here we have num is equal to 2 and that sum is equal to 17. So we know that the n that we're looking for has 2 digits because num is equal to 2. And now, what is the largest number that you can think of which has 2 digits? So we can start our sample space of searching for the n by the maximum, which will be 99, which will be basically n in the string the num number of times, right? Because that's where we will start our search, and that is where we should start our search, because the question is asking you to return the maximum n that is possible. So we're starting with for this example that the current number is 99, but the sum comes out to be 18. The sum that we want is 17. So we can do a difference here to know that we have a difference of 1, which we need to remove from the magnitude of these digits in our current n in order to get the desired sum, right? So that will be the basis for us to form an algorithm which we will use to arrive at our answer. Basically, you start with identifying where you can start where you can start your guess for n with, which is the maximum possible, and then you find out the difference between your current n and the current n the sum of the digits of n and the sum of the digits of n that you want it to be. So when you have this difference, you take this difference and you keep minimizing this difference in such a way that it becomes 0, and finally whatever n you are left with will be the answer that you return. So when you're making it 0, it's best, how you make it 0 is that you start with the rightmost digit and start making it 0. If suppose the difference, let me scroll a bit more. If the difference was something that is more than 9 and your number that you're starting with is 9, your sum is, let's say, 5. So how you can do this is, so the difference in this case would be 18, which is 9 plus 9 minus 5, right? Which comes out to be 13. So I know that I need to remove this 13 amount from either of these digits. So first I choose the rightmost digit and then I make it 0. So then I'm left with 9. So now the current difference from 13, it becomes 9 minus 5, which is 4. Now I know that I need to remove 4, and I'll do that by removing it from the rightmost digit that I am currently at, because I can't remove any more from 0. I'll remove the 4 from 9 and I get 5, 0, and this would be my answer. Now you may say that we, instead of having 5, 0, we can have another answer like 4, 1. This would also satisfy the condition that num is equal to 2 and sum is equal to 5, right? But the sum of squares in this case would always be lesser, much lesser than the sum of squares when you are always considering the rightmost digit when you're going through your current n. And that's because we're doing the magnitude of the number. I mean, the score of this is decided by squaring each of the digits, and having the most in one digit, the square of that will always be much greater than in the squares of smaller numbers. So that's how that's the basic algorithm and solution to solve this problem. And now I'll be showing you the code which got me 85%, which beats like the 85% of solutions. Let me make this bigger. So yeah, here you're seeing that I have started a variable called max num, which is my initial guess, and the max sum is basically 9 into the number, and I'm initializing my difference to the max sum, which is 9 into the number minus the current sum which they've given me in the question. Then I am saying that if the difference is less than 0, then return empty string. This is because if the difference is less than 0, it's not possible to make a number. So this is one of the edge cases. Then I start with iterating through all of the digits. Basically, I'm checking if the difference is less than 9. That means that I can remove whichever digit that I'm currently at, I can remove its magnitude by the difference, right, if it's less than 9. And if it's less than 9, that means that I've already found the answer, the n that would satisfy all the conditions and is the maximum. And so what I'm doing is I am adding the current digit to my answer. Basically, my answer is the final string that I'm building, which I'm returning at the end. And then to this answer, I am also appending 9 num minus I times. This means that all of the difference is completed. I mean, the difference that we're removing from the magnitude of each of the digits is completed. And to maximize the sum of squares, I'm adding the rest of the digits. I'm blankly filling them to be 9. I just return that, and I mean, I make the string out of it and return it. So I'm returning it in a way such that I'm just sorting out, I'm doing like a descending sort on my answer string, and I'm returning that. This is just so that like I'm not having any zeros in the beginning, any zero padding and all of that. Then again, if my difference is greater than 9, then that means that I need to go through more iterations of this in order to find the n that I am searching for, right? So all I do is that I take the rightmost digit and then I subtract all of the magnitude from it. That's basically the same thing as adding a 0 to my n string, n, which is my answer. And finally, because I am subtracting 9 from the digit, which is the highest thing I can subtract in this iteration, I'm updating my diff variable. And at the end of this loop, if I never find that the difference is less than equal to 9, that means that the difference is more than what I can remove, than what I can ever make, from this, from the 2 digits. So that means I again don't have an answer. So this is the code to solve the problem. So yeah, that's it for this video. Thank you for watching.